So, my name is Shafqat, and I will talk about our recent experiments with the open domain translation in GF. So, some backgrounds, as most probably you know more about it. So, we have this GF resource grammars that Arne talked about. These are general purpose computational grammars that we can use as libraries to build application grammars. And these grammars encode different morphological and synthetic constructions, and historically they have been used to develop different application grammars, like framework, WebArt, and few others. So, with this robust parsing in GF that Charisma talked about, we started thinking about it. Can we, really use these resource grammar for building wide coverage language translators? And said, yes, why not? Let's try and see how it goes. But the very first requirement to build wide coverage language translators was to have bilingual lexicons, even though we thought about doing this with unilingual lexicons, but we started with first of all experimenting with this bilingual lexicon and then maybe considering the other options as well. And our first experiment was for this Hindi-English translation, rather English to Hindi translator. And we got an English-Hindi dictionary from the Pushpak group, and using that bilingual dictionary, I ended up with a GF Hindi dictionary that was parallel to the English dictionary that Charisma is using for parsing the pen tree data. But this dictionary is not, it's not a full, the coverage is not full yet. We have around about 43,000 words in our English dictionary, but the parallel Hindi dictionary that I produced from Pushpak dictionary has around about 26,000 words. So using now the English and the Hindi resource grammars that we have, and the parallel dictionaries that we have, we can now use the English source text, and using the GF robust parser, we can get the parse trees, and then we can we linearize those parse trees to any target language for which we have the resource grammar and the dictionary, and Hindi in this case, first of all. And the experiment we did to evaluate these translators was that I got a set of sentences, parse trees from the pen tree book from Charisma, and then I selected randomly 100 sentences from this set and produced two candidate translations, one with Google and one with our resource grammar and this bigger lexicon. And now, in order to evaluate the translation produced by our system, we need the gold standard, and we produced the gold standard by post-editing the translations, the two translations, one from Google and one from resource grammar. I took 50 sentences from that was translated by resource grammar and the other 50 from the Google, just to avoid that the fact that the gold standard is not biased towards either Google or either resource grammar. So we got a random mixture of these sentences, and then we handed over these 100 sentences to one or a couple of our evaluators, and by post-editing those translations, we got our gold standard, so to say. And then with this, with these translations produced by Google and by our resource grammar, and with that gold standard, and then we have this ACR online evaluation tool that Ramon talked about before this one. So it's an online toolkit for automatic machine translation evaluation. We need source text, we need reference translation, gold standard, and then we can provide one or more system translations, Google and GF in our case. And using this online evaluation tool, we can get different evaluation measures like word error rate, other and blue scores as well. So for English and Hindi translator, I ended up with these results, and these are very, I mean, the experiment was very recent, even a day before starting this workshop, and I could not have time to analyze it, but I wanted to share it with them. So we can see that for English and Hindi, our resource grammar, I mean, without any extra effort, I mean, just whatever we have, we got the dictionary, have the resource grammars, and we started with this baseline that our system was better than the Google Translate in this English and Hindi case, because we got this blue score 0.34, and with blue we have this 0.30. And we also have a bigger lexicon for Finnish that Arne provided, and using Finnish resource grammar and that dictionary and the English and its resource grammar, I repeated the experiment for this English and Finnish, and still here we have better results as compared to Google for this experiment. And also we did the experiment for German. We have a German lexicon of around about 15,000 words, I guess. But here, for English-German, the Google Translate was, the translations are better than the resource grammar translations. And an important factor that our observation was that the lexical choices in bilingual lexicons are very important, because you know that the mapping is one to many. For one English, in the Tagalog language you might have more than one words, but this lexicon is just one-to-one mapping, so it's very important that which word we selected for the corresponding English word. So the lexicon can improve the results, and we did this one for Hindi, and after just playing a little bit with the lexicon and the lexical choices that we made for English in the lexicon, after changing few entries and more frequently occurring words, when I repeated the experiment, and I got much better results as compared to previous results. Previously it was 0.34, but now we got the results improved from 0.34 to 0.37. So that was mostly what I wanted to say.
So where did you get your German lexicon from, and did you do the same tweaking?
That was produced by one of our students here.
I think it was from Wiktionary and from some other.
But did you do the same tweaking on a German lexicon?
No. We just did
and
this.
And in the error analysis, was the problem in German because of lexical choice or because of bad syntax?
I think we don't have done any analysis yet, because I just got these scores.
So one problem was that for some reason these test sentences were very short, and you couldn't. They had kind of the main clause word order.
So Google was lucky.
So yes. So
yeah.
And the other source was negation. So there is something which we haven't decided how to do this, where to do this exactly, because German has two negations. So you have the verb negation with nicht, and then the noun negation with kein.
Kein.
And if you use the raw resource grammar, then you use kein to translate no, and nicht to translate not.
Yes.
And many of those errors came from that actually. So that the evaluator marked those as errors, and Google had got them right. So.
How many changes do you know? How many you made in that last tweaking? How many words? About hundreds or tens of words? Or
I think it was around about 50 words that you changed in the lexicon, for sure. That the list that I provided, and then you just reversed it for our first 50 sentences experiment that we did. So it was, I think, a list of about 50 words.
If you need to choose a default translation, the obvious thing is to take a parallel corpus and take the most frequently aligned translation and filtering through your bilingual works.
Yeah, I think it depends on how much parallel data we have.
Mm.
Because I did this experiment for Urdu and English, and the results were very terrible. Because we don't have much data. For
Thank you.
All right. Thank you.